weld begins with a W. These are some super ugly looking welds. Or, well, actually, they're technically not considered welds. But these, though, these on the other hand, these are actually welds, and they are also super ugly for a very good artful reason that I'll show you a little bit later. Now, I'm only calling attention to the ugliness here because you're going to see a lot of it. And if you can stomach them for the duration of this video, well, then you'll probably learn something really cool about TIG brazing, which you might not know about. And if you get the same stuff that I have here, you can actually follow along and build your own. It's going to be really neat. Now, the welding industry I am most directly involved in is automotive performance fabrication. I build really awesome cars, and on the side, I do a lot of weld repairs on parts and related. But sometimes I really like to make something cool, like art pieces, and I use these to practice and sharpen my welding skills, or maybe even learn something new. Now, today's project is exactly that. I'm taking 3 welding challenges from weldmetalsonline.com, and I'm going to build a really cool looking piece to sit in my lobby. 2 of these pieces are the Diamond Gem Kit. One is made out of stainless, and the other is plain old carbon steel. The third piece is going to be the stainless steel triangle pyramid. And to stick them all together, I'm going to use silicon bronze. That's mostly because steel and stainless steel don't mix very well, and silicon bronze is actually some really cool stuff. My reason for using both steel and stainless steel is to create a really unique contrast to the final piece. I'd like the steel to rust and the stainless steel to stay clean, or without the rust. Now, to better explain why stainless and carbon steel don't mix, I asked metallurgist and fellow YouTuber Tim from Tim Welds to give us a quick 42-second explanation.
So here's what's happening. You have carbon steel and stainless steel, which have each been engineered with certain elements in very specific amounts. Now, in this type of stainless steel, you have 2 elements that matter the most. You have chromium, which helps keep it from rusting, and nickel, which is added in a very specific balance to give you the right structure of atoms and ultimately the properties that you want. Now, when you mix together the stainless and carbon steels, you end up with a new material that was never engineered to begin with. This can lead to weld cracking as well as poor properties. However, using a filler metal designed for this purpose like 309 makes it possible to successfully weld these 2 materials together, which is done every day.
Couldn't have said it better myself. Thanks, Tim. Now, I can weld 2 metals together all day long. That's not very big of a deal. But like I mentioned earlier, I also want to practice a skill that I rarely ever use, which is TIG brazing with silicon bronze, and that's not welding. So, what is brazing? Well, brazing is a term used to describe joining 2 pieces of metal with a filler material. It sure sounds a lot like welding, doesn't it? Well, it's actually not. The definition of brazing has 2 key words in it that separate it from welding. They are joining and filler. Joining metal is not the same as combining metal. In welding, we combine the base metal by melting it together, which essentially mixes it together before adding a filler, which adds to the strength of it. In brazing, only the filler material is melted into the joint, and a cool scientific thing called capillary action draws the liquid filler into the joint while the base metal stays solid. Capillary action kind of sounds like one of those super educated words for something you've probably seen, whether you realize it or not. Take a look at this napkin. Notice how the water defies gravity by crawling up the surfaces of the napkin? That's capillary action. The filler metal in brazing basically works the exact same way. If we liquefy the filler, it crawls or flows automatically into the joint all by itself as long as we keep it liquid. Once it cools and turns to a solid, it holds the pieces together kind of like a hot metal glue. But before we can go slapping filler into this project, we first need to assemble it. Assembly of the Weld Metals Online Diamond Challenge is pretty easy. I'm starting this one with the stainless steel top instead of the steel one. I mean, if I don't like it, well, I'll just have another chance to build it because I bought 2 kits, right? I carefully lined up each piece to attach to the top, alternating between steel and stainless before running an autogenous tack. If you don't know what an autogenous tack is, it's basically saying that it's a weld without the use of filler. You simply heat up both pieces until they combine and stick together. This is really useful for holding pieces of metal together so you can move an assembly around or, in this case, manipulate the assembly into a shape. Of course, we mentioned that stainless and carbon steel do not mix very well. So just sticking the two together with a small autogenous tack weld will definitely make them crack once you try to bend the assembly into a shape. So we're definitely going to have to add a little bit of filler to keep that from happening. So what is the filler then? There are several brazing fillers available for different purposes and even different processes. The one I am using here is probably the most popular brazing filler, called silicon bronze. Now, without geeking out about metal, silicon bronze is basically an alloy blend of copper and silicon. I'm guessing that's because it's round in shape, but who knows. There's also some other elements sprinkled in, like tin, manganese, and zinc. Mix them all together, and after some metallurgical magic, we get silicon bronze. Okay, I lied just a little bit here. There's actually no silicone in the filler. It's silicon that's in the filler. There's no E, and it's not synthetic. It's a natural occurring element. So in short, the brazing process sticks many metals together without combining the metals. The trick is to use the arc from the TIG as only a heat source to melt only the silicon bronze into the joint. It generally takes less amps to achieve, and the resultant technique is just a little bit different. And of course, I'll show you how TIG brazing is different in just a moment once we get this diamond fully assembled. Now, after tacking everything together and getting it into shape, you might find that the piece is slightly out of alignment. This is easily fixed by grabbing a decent-sized hammer, like a ball peen, and tapping down on the high sides. The loosely held tacks will shift just enough to knock it into alignment. The lower section of the diamond requires a bit more bending. It probably wasn't seen very well on the top section, but pretty much every tack that mated the stainless to the carbon actually broke. This time I'm not going to chance it since these 7 pieces require a bit more bending. So once again, a few tacks with silicon bronze held it all together as I folded it up. It takes a bit of patience to get it to align just right, and the hammer trick also works well to knock everything into alignment. Now that the top and bottom sections are tacked and shaped, we can make them. You might find that a section or two does not align perfectly, and that's no big deal as long as you start by tacking the sections that do align together first. You can then grab a hammer and tap everything into alignment right after that. It's best to take your time and get it aligned just right. Now, if you missed on a tack or something doesn't quite look right, don't be afraid to cut it all off and rework it. Once you're happy, grab your filler and let's start brazing it. Now, as mentioned earlier, we only use the arc as a source of heat for only the filler. So you first have to light up the arc ever so delicately. Slide the filler under it until it melts the filler and watch as the filler flows and advances. Then slide the filler back in to repeat the process. The entire time you should have the arc focused entirely on the filler metal or the bead that you just created and not the base metal itself. Remember that we're not trying to combine these metals, we're just trying to melt the filler in to stick them together. Now there are a handful of techniques to use and practice when brazing. I chose to primarily work with my foot pedal to control the amount of amps I was putting into this part. It takes practice to keep it just right, and don't worry if your resulting beads kind of look like crap. Nobody was blessed with a golden skills meant for perfect silicon bronze when they were born, so don't be too disappointed if you just tried this out for the first few times and ended up with results like mine. It's totally normal. Gas cups and flow rates are a common topic when laying down some silicon bronze. You really don't need tons of argon coverage for this stuff to work. I'm using a number 8 cup with a stubby gas lens set to about 15 CFH of argon flow. You could step it up in size to a number 12 at about 25 to 30 CFH if you want to, but the result will probably be pretty close to the same depending on what you're actually brazing together. Pulsing is also a popular method for working with silicon bronze. Now, pulse is something that I rarely ever do since my discipline is what you call hot and heavy. I'm like an in-out, hello-goodbye kind of welder. To me, pulsing takes more time, which is really boring. Either way, I ran a few beads with the pulse set to 30% on time with a 10% background current. To offset the now less time with the arc lit, I had to turn the amps up to 100 from the 70 I started with when the pulse was turned off. The results were about the same, but it was kind of cool to practice, even though this is super boring. Now, some people ask what happens if you accidentally put too much power into the part and liquefy the base metal. Well, the answer is, in most cases, absolutely nothing happens. Most metals being brazed have trace amounts of the same alloys as the filler. They'll technically still stick together or combine, but that wouldn't really be brazing at that point, it would actually be welding. It's time to clean this piece up, and the reason that I didn't really care what the beads look like or how dark the metal became after brazing is because I'm going to clean it all up. I do have to be kind of careful about this if I'm going to achieve the desired rust effect though. I started with an 80 grit flap disc on my grinder to knock down the silicon bronze beads. Now this does technically contaminate the stainless steel because the same disc is being used to grind the carbon steel, which will impregnate the stainless with carbon on the surface of it. At this stage, it's actually no big deal since we have a few more stages to go in order to finish this piece. Next, I tried to knock down most of the grinding marks with 80 grit sandpaper. This brought everything down to a nice uniform finish, and if I wasn't going for a cool rust effect on the steel, I'd probably leave it like this. The next step is to find and mark out the steel so I can avoid it during the stages of polishing. The easiest way to find it versus the stainless is with a magnet. The magnet sticks to the steel, but not the stainless. With the steel all marked out, I grab 3 different grits of 5-inch surface conditioning discs. Each one of these grits gets finer and finer as the color changes. I have 3 for stainless and 3 for steel. The reason for separating them is so that I don't contaminate the other metals. These will also remove the impregnated steel from the previous grinding and sanding operations, meaning it shouldn't surface rust. I finished the stainless all the way with a very fine disc, and this brought it to a decent uniform shine, just a couple stages shy of being mirrored. I then hit it with a red prep pad to add a little bit of a brush finish. The steel was only taken down with the red surface disc because I need it to be slightly rough for the rust solution to work. After getting the diamond finished the way I like it, I moved on to the stainless triangle pyramid. This will actually be welded, and just like before, I'm totally trashing these welds. I'm also using regular ER70S-2, which is a mild steel wire. I'm using steel wire on purpose because I want to see if I can make the weld seams rust while the stainless stays non-rusted. I've never really tried this before, so we'll see here if it actually works or not. Once I completed the finish work on the pyramid, I stuck it to the diamond using some silicon bronze. As it sits right now, I really like it. Over the course of time, the steel will naturally rust, but I'm actually way too impatient. The fastest way to make steel rust is to mix 2 parts of hydrogen peroxide with 1 part vinegar and add some salt. Throw all of it into a spray bottle and grab a torch. The torch heats up the part slightly and burns off any moisture on the part. It also makes the silicon bronze stand out just a little bit. After a few heavy sprays with the rust solution, we can see how it looks. I let it sit for about 15 minutes before I rinsed it off with water. This is definitely a really cool piece, and if you want to see it in person, it will be on display in my lobby here at TFS in Las Vegas. That's about all I got. I want to thank you guys for watching, and definitely a special thanks to Tim Welds for helping us out. Make sure you subscribe to both of our channels, and I'll see you guys on the next episode.